Good afternoon, everyone. I'm 严珮华and my teammate is Li. Today we are going to introduce the diffusion pump, which is an important type of high vacuum pump used in many vacuum systems. In this presentation, I will first explain why high vacuum pumps are needed. Then we will talk about that diffusion pump is, how it works, and what its main components are, what the principal issues should be considered, and finally we will briefly compare it with the torn pump. Before introduce the diffusion pump, let me first ask a basic question: why do vacuum systems need high vacuum pump? A reason is that a vacuum system usually cannot reach very low pressures in just one step. Instead, the pressure is induced in stages. At the beginning, a mechanical pump is used to lower the pressure from the atmospheric pressure to the raw vacuum range, but the mechanical pump only use cannot achieve deep high vacuum. As shown on this slide, there are several pressure range. Raw vacuum is about 1000 to 1 millibar. Medium vacuum is 1 to 10 to the minus 3 bar. High vacuum is 10 to the minus 3 to 10 to the minus 7 bar. And below that is ultra high vacuum. So the pressure becomes lower and gas flow enter the molecular flows region. A high vacuum pump is needed to take over. This is where the diffusion pump starts to play its role. So the diffusion pump does not work from the very beginning. It works only after the chamber has already been pumped by the root pump. Now let's move to the main topic. What's a diffusion pump? A diffusion pump is a high vacuum pump that uses a high stiff vapor jet to push gas molecules downward and remove them from the system. In the simple word, it does not use high-speed rotating blades like a turbine. Instead, it uses heat pump fluid vapor to create the first vapor jet, and this vapor jet carries the gas molecules away. Because of this, it can also be described as a momentum transfer pump. There are several important features of a diffusion pump. First, it is designed for high vacuum. Second, it does not have the high-speed rotate structure found in a turbopump. Third, its concept is relatively simple and its structure is durable, so it is often considered turbo simple to the cost effective. Also, modern diffusion pumps usually use oil as the pump fluid instead of the mercury used in early designs. So if I explain it in one simple sentence, a diffusion pump used a fast vapor jet to carry gas molecules downward. This side connects the work participle to the actual machine structure. The main components include the heater and boiler, which generate the vapor. Then there is the nanostate, which determine how the jet is formed and how many compression stages are used. There is also the cold word or collateral line, which condense the vapor, which high vacuum flanges connect to the pump to the vacuum chamber. The back connection sends the gas to the fuel pump, and finally baffle or cold cap is often added to reduce oil backstream. Basic the components themselves. Other important concept. There is the operating window. A diffusion pump does not work equally well as every pressure within its normal working range, which is about 10 to the minus 3 mbar or below. The pump speed is almost stable, but if the inlet pressure becomes too high, the vapor gel will be distributed and its pump speed will drop clearly. So the key point of this sign is whether a diffusion pump works well dependent on not only one on switching in its on, but also whether the heat, geometry, pressure, conduction, and cooling are all the right range.
So this slide covers the very practical and important part of the diffusion pump. First, let's talk about the pump fluid. Modern diffusion pump usually use the special mineral oil or the silicone oil. When choosing a pump fluid, there are several things to consider. The first is the vapor pressure because it affects the retrieval automatic vacuum. The second is the thermal stability because the fluid is continuously heated during the operation. The third is oxidation resistance, which becomes important when the pump is exposed to the air. And next is cooling. Most diffusion pumps need water cooling because if the vapor cannot condense effectively on the wall, the whole pumping cycle cannot be completed properly. The book also mentioned that the smaller oil diffusion pump may sometimes be air-cooled, but the water cooling is still the most common method. The third important point is the backstreaming. This is one of the disadvantages of the most often mentioned for the diffusion pump. The backstreaming means that some pump fluid molecules may move back toward the vacuum chamber and contaminate it. To reduce this problem, the system usually uses the buffer of the cold trap. However, also this device reduces the oil backstreaming. They usually also sacrifice a little conductance of the or the pumping speed. Also, the actual ultimate pressure depends not only on the pump body itself, but also on the vapor pressure of the pump oil, the cleanliness of the system, the condensation efficiency, and how well contamination is controlled. So, whether the diffusion pump performs well depends not only on the machine itself, but also on the overall system condition and the maintenance. And next is the advantage. After introducing the principle and the operation, let us now look at the advantage of the diffusion pump. The first advantage is the high pumping speed, because it can have a very large inlet diameter. It is attractive in systems that require a very high throughput. The second advantage is a simple internal concept. Unlike the turbo pump, it does not need a high-speed rotor or a complicated mechanical balancing. The pumping action mainly depends on the vapor jet. The third advantage is that it is cost-effective for industrial use. If the system mainly needs a high pumping speed and a stable industrial operation rather than the cleanest possible vacuum, then the diffusion pump is still a very practical choice. The fourth advantage is that it is still a reliable workhorse. Even today, the diffusion pump are still widely used in the coating or the heat treatment. So overall, also the diffusion pump is not the newest high vacuum technology. It is still a strong value in terms of the high pumping speed, industrial use, and the cost effectiveness. and the limitation. So, of course, every machine has a limitation, and the diffusion pump is no exception. First, it always needs a backing pump. It cannot start working directly from the atmospheric pressure. Second, it needs a stable cooling. Otherwise, the vapor cannot condense properly, and overheating or re-evaporation may occur. Third, it has a risk of oil backstreaming. If the buffer trap or operation procedure is not handled properly, the vacuum chamber may become contaminated. Fourth, the pump oil also age over time, so disgassing, cleaning, or replacement is necessary. In real systems, several protection mechanisms are often added, such as the cooling water monitoring and the thermal switches, and interlock to make sure the diffusion pump cannot run without the full pump support, and monitoring whether the backing pressure is approaching the critical floor pressure. And next is run for abnormal pressure rise. So the main message of this slide is it is not that the diffusion pump cannot be used. Instead, it strongly depends on the good system design and the good operation habit. If it is designed well and maintained well, it can work very effective. But if cooling, floor pressure, and oil management are neglected, the gravity problem can happen easily. So the typical application in this slide lists several typical applications, including the vacuum coating and the metallizing, and the heat treatment and the vacuum furnace. And next is brazing and protective film deposition, and optic and electronic coating lines, and some research and development system. These applications have one thing in common. They all require a stable and strong high vacuum throughput, and they can usually accept a somewhat more complex system. In other words, in this field, the high pumping speed and the industrial durability of the diffusion pump are often more valuable than its disadvantage in the cleanness. Finally, I would like to make a summary. First, the diffusion pump is a high vacuum pump. It does not rely on the rotating blade, but instead uses a heat vapor jet to carry gas molecule toward the exhaust direction. Second, it is best used as a part of a complete system. That meaning the vacuum pump, cooling pump, fuel selection, and the backstreaming control are all very important. The third, also the turbo pump are now more common in many clean high vacuum systems. The diffusion pump is still very valuable in the industrial high throughput applications such as the coating furnace and other similar process. So overall, I will describe the diffusion pump as important but still practical industrial high vacuum pump. It is not the cleanest option, but it still has a very clear advantage in the high pumping speed, durability, and the cost effective. That is our presentation. Thank you.我知道要念多久？我要怎么看我念多久？
你先结束就看得到。我真的可能要先回家了。
那我觉得后面念的有点乱。